A promise, I'm back. Good evening once again. Welcome to today's video. We are going to be looking at what we call the autonomic effect on what we call salivation process. Let's go ahead and get started, okay? When we talk about the autonomic effect on what we call the salivation process, we want to see what is going to be the sympathetic effect salivation process and what's going to be the parasympathetic effect to the salivation process, okay? So now what's going to be the effect, general effect of those two systems on what we call the salivary gland? That's what we are going to be looking at generally, okay? So now we are going to be having this side being for sympathetic nervous system and this side going to be for parasympathetic nervous system. Okay, so now this side is going to be for sympathetic nervous system and then this side is going to be for parasympathetic nervous system. Okay. Now, here we have just brought a diagrammatic illustration showing the different salivary glands, mainly the extrinsic salivary glands. Okay. Now, we have this one here, which is just going to be just inferior to the ear, just slightly anterior. This is what we call the parotid salivary gland. This is one of the major extrinsic salivary gland. And then this one here, just on the mandible, is what we call the submandibular salivary glands. Okay. And even this one under the tongue is what we call the sublingual salivary glands. Okay, one more time. This is the parotid, this is what we call submandibular, and this is what we call the sublingual salivary gland. So now let's go ahead and see what is going to be the effect of the sympathetic nervous system and then even also what we call the parasympathetic nervous system. Okay. So now parasympathetic nervous system is always activated whenever we are at rest and we feel like we want to digest. This is the most important thing we need to first know, okay? It is during the parasympathetic nervous system that we want to rest and then we want to digest, meaning that we need more of the saliva secretions, okay? And then of course when we are under stress, something is chasing us, something where there's too much of the emotional. This is where we are going to be having limited secretion of what we call the saliva, okay? And in this case, you're going to be having the very 2% of the saliva being secreted, and it's going to be more viscous and then thick. Okay, so now let's go ahead and see how is the parasympathetic nervous system going to be affecting the salivation process of these different extrinsic salivary glands. Okay, so now we first need to know what is going to be now those stimuli for the case of the salivation process. What are those kind of the stimulants that are going to be stimulating what we call the salivation process? We have the following. First of all, we have what we call sight. Okay, we have what we call sight of food. We even have what we call smell. Okay, we have what we call smell. We even have what we call taste. Even have what we call taste of food. And even also have what we call thought. Okay, what we call even thought. So now these are going to be the stimuli for the salivation process. They are the one which are going to be causing different kind of stimulation of different kind of innervations that will lead into the salivation process. Okay. Now, for example, when you look at the food, the information is going to be taken to the brain via what we call the optic nerve, and then the information will be taken to what we call the vision centers. And the vision centers are going to be located in the occipital lobe. This way, we are going to be having what we call the visual cortex. Okay. So now, if it is taken to the visual cortex, which is going to be located on the occipital lobe, it will give off. Now, this visual cortex is going to be giving off fibers. Okay, it's going to be giving off fibers, and these fibers will come and activate one of the portions of this structure, which we call the hypothalamus. Okay. The hypothalamus is going to be a regulator of the autonomic nervous system. It's going to be having the sympathetic part, and then it's going to be having what we call the parasympathetic part. So now, when it receives the messages from the visual cortex about the kind of the food we have seen, now it means that we're going to be activating the parasympathetic portion of the what we call the hypothalamus. Okay. Now, the hypothalamus is going to be giving off fibers, okay? It's going to be giving off axons, which will move down and come and stimulate this kind of the nucleus, and even also will come and also stimulate this kind of the nucleus. So now, how do we call this nucleus, and how exactly they are going to be leading into innervation of these salivary glands, okay? So now, this kind of the nucleus, which is just going to be on what we call the pons, just on the inferior aspect of the pons. This one here is what we call the superior salivatory nucleus. Okay, this one here is what we call the superior salivatory nucleus. Now, The severe salivatory nucleus is going to be giving off fibers, These fibers are going to be running with what we call the cranial nerve number 7. So now we are going to be having here cranial nerve number 7. Okay, we're going to be having here cranial nerve number 7, and then this cranial nerve number 7, as it moves, is going to be having this kind of the sensory ganglion. Okay, there's this kind of the sensory ganglion, and this sensory ganglion is what we call the geniculate ganglion. Okay, it is a sensory ganglion. Now, on this ganglion, you're going to be having two main branches. Okay, we're going to be having two main branches. We have this branch here down here, and then also have this kind of this branch here. This branch is going to be what we call the greater petrosal nerve, which is going to be also allowing the movement of parasympathetic fibers that will terminate on what we call the pterygopalatine ganglion, from where they go and innervate what we call the lacrimal glands. Okay, but our target is what we call the salivary glands, meaning that we also have this kind of the branch direct from the geniculate ganglion. This kind of this branch here is what we call the coda, the coda tympani. Okay, the coda tympani. So now our parasympathetic fibers are going to be moving along this kind of the facial nerve, and then it does not synapse in this ganglion because this is a sensory ganglion, and then it moves down through what we call the coda tympani. Now, from there, this kind of the parasympathetic fibers will come, and then they terminate to a certain kind of this ganglion. You know how we call this ganglion where these parasympathetic fibers are going to be terminating? This ganglion here is what we call the submandibular ganglion. Okay? This ganglion here is what we call the submandibular ganglion. Okay? What we call submandibular ganglion. And then from there, the postganglionic motor fibers of the parasympathetic nervous system are going to be leaving. They come and now release different neurotransmitters to this kind of salivary glands. Primarily the submandibular salivary gland and then the sublingual salivary glands. Now, when it reaches here, it is going to be releasing a neurotransmitter called acetylcholine. Okay, and then acetylcholine is going to be stimulating these salivary glands, leading to an increase in salivation process. Okay. So now that is how the parasympathetic fiber through what we call the facial nerve leads into salivation process of what we call the sublingual and then submandibular salivary glands. Okay. So now how about the parotid salivary gland? We also need to know how the parotid gland also gets innervated. Okay. We also need to know how the parotid gland gets innervated. That was only for submandibular and then sublingual salivary glands. Now, for the case of the parotid gland, we have this nucleus here. You know how this nucleus is called? This nucleus here is what we call the inferior salivatory nucleus. Okay, inferior salivatory nucleus. It is going to be giving all preganglionic fibers. These fibers are going to be moving with one of the most important cranial nerve. You know how this cranial nerve is called? They are going to be moving with what we call cranial nerve number 9, and that is glossopharyngeal nerve. Okay, so now we are going to be having the glossopharyngeal nerve. The glossopharyngeal nerve will move and then pass out through what we call the jugular foramen. It is going to be moving. So now our parasympathetic fibers from the inferior salivatory nucleus will move along with this kind of glossopharyngeal nerve, and then it will come and terminate in this ganglion. You know how we call this ganglion? This ganglion here is what we call the otic. The otic ganglion. Okay, the otic ganglion. And then from there, we are going to be having what we call the postganglionic motor fibers of the parasympathetic nervous system coming out slowly, and then they go and stimulate the parotid salivary gland, leading into the production of what we call saliva. Okay. So now that is how the parasympathetic nervous system is going to be leading into the salivation process. The neurotransmitter which is going to be released on these structures is what we call the acetylcholine. Okay? So now that is for the case of the parasympathetic nervous system through what we call facial nerve and even also what we call the glossopharyngeal nerve. okay, and then into these structures as you have just seen, okay. So now let's look at what we call the sympathetic nervous system. Now, sympathetic nervous system is always activated whenever we are stressed, and then even there's something which is stressing us, or even there's even what we call some kind of what we call the emotionals. Okay, that's when you're going to be having the sympathetic nervous system getting activated. Okay, so now how is it going to be getting activated exactly? Now, for example, when you see something like a lion and you see that this lion is not friendly to us, this information is going to be picked by the optic nerve. It's going to be taken into the different cortex within what we call the brain. What happens that the information is going to be relayed to one of the most important structure that regulates, that has what we call the fearing centers, which we call the limbic system, but primarily on the structure which we call the amygdala. Now, the amygdala will give off fibers that is going to go to one of the most important structure here. This structure here is what we call the hypothalamus. So now the hypothalamus will receive information from the amygdala about the scaring lion that we have seen. Now, what happens that the sympathetic portion of the sympathetic portion of what we call the hypothalamus is going to be activated. Once it is activated, it will give off fibers which will move through the brainstem and moves down. When they move down, they are going to be now activating all the cell bodies of the sympathetic nervous system. Okay? All the cell bodies of the sympathetic nervous system are going to get activated. All the cell bodies of the sympathetic nervous system are going to get activated. So now, when these all cell bodies are activated, now we need to first know from where do we find generally the sympathetic nervous system? We find it from what we call the thoracolumbar region, okay? Mainly from T1 up to L2, okay? So now we are going to be having now the preganglion motor fibers from what we call, they are going to be coming generally from what we call from T1, even also from T2, even also from T3, and even some little part of it may be from T4. They are going to be coming and they pass through what we call the sympathetic chain ganglia. They are not going to be synapsing, okay? Now, these fibers, these preganglion motor fibers of the sympathetic nervous system will move up and pass through what we call the inferior cervical ganglion, the middle cervical ganglion, and then to the superior cervical ganglion. Now, in the superior cervical ganglion, this is where these fibers are going to be terminating. Now, when they terminate in this cervical ganglion, superior cervical ganglion, you're going to be now having the motor fibers of the sympathetic nervous system getting activated. Now, when they get activated, you're going to be now seeing the postganglion motor fibers coming out. When they come out, in the neck we have what we call the carotid, the common carotid artery that splits into the internal and then the external carotid artery. Now, these postganglion motor fibers of the sympathetic nervous system, they will come and then coil on this carotid artery, and they make this kind of the plexus, which we call the carotid plexus. Okay, the carotid plexus. And then from there, these postganglion motor fibers, they are going to be now coming and then they start innervating the parotid salivary gland. Will come now, also some branch come and innervate what we call the submandibular salivary gland, and even also we shall have another branch that goes and then even also stimulate what we call the sublingual salivary gland. Now, what is going to be the general effect? The general effect is that we are going to be having reduced saliva. Okay, we're going to be having reduced saliva secretion, and the little saliva which is going to be produced is going to be very thick. Okay, it's going to be very thick and viscous. Okay, and viscous. Generally, sympathetic nervous system is going to be reducing salivation process, but the little saliva which is going to be produced is going to be more thick and it's going to be even more viscous. And then when we come to the parasympathetic nervous system, it's going to be increasing. It's going to be increasing salivation. Okay, it's going to be increasing salivation, and the saliva which is going to be produced is going to be generally watery, and then even also enzyme rich. Okay, this one here for the sympathetic nervous system, this saliva is going to be thick and viscous, and is going to be rich. It's going to be rich in what we call a glycoprotein called mucin. Okay, And of course, it's this protein called mucin that makes this saliva to become a bit thick. Okay? So now that is what we call the innervations or the salivary glands for the kind of sympathetic nervous system and then the parasympathetic nervous system. Let me just have a very simple quick recap of what we call sympathetic and then parasympathetic nervous system. We have said that the parasympathetic nervous system is always activated whenever we are at rest and then we want to digest. This is when we need more of the saliva secretions, okay? And then we have said that whenever the parasympathetic portion of the parasympathetic nervous system is activated, it will move down to give off axon fiber that will activate this kind of the nucleus. The superior salivatory nucleus that will give off parasympathetic fiber through what we call the facial nerve, that will pass through what we call the chorda tympani, and then terminate on what we call the submandibular ganglion that will give off postganglion motor fibers to go and innervate submandibular and then the sublingual. Then we said also have what we call stimulation of what we call the inferior salivatory nucleus that will give off preganglion motor fibers of the parasympathetic nervous system through what we call the glossopharyngeal nerve that will terminate on this ganglion which we are calling the aortic ganglion, from where the postganglion motor fibers will come out and then come and innervate specifically what we call the parotid salivary gland, leading into what we call increased salivation, of which the saliva is going to be watery and then enzyme rich. Okay, that's for the case of the parasympathetic nervous system. Now, for the case of the sympathetic nervous system, we are stressed. They are chasing us. We are going to be seeing activation of these cell bodies of the sympathetic nervous system, which are going to be located in what we call the thoracolumbar region, mainly from T1 up to L2. Now, when these fibers from the sympathetic portion of the hypothalamus activates all these cell bodies, you're going to be having now the preganglion motor fibers from T1, T2, T3, and even T4 coming, and they pass through what we call the sympathetic chain without synapsing. They move up through what we call the inferior cervical ganglion, the middle cervical ganglion, and then the superior cervical ganglion. In the superior cervical ganglion, that's where they're going to be synapsing, from where the postganglion motor fibers of the sympathetic nervous system will leave and then coil around what we call the carotid artery, forming what we call the carotid plexus, from where they will come and now and innervate all these structures which are calling the parotid, the submandibular, and then the sublingual, leading into reduced salivation process. And of course, the little saliva which is going to be produced is going to be thick, viscous, and having a protein which we call mucin that makes the saliva to become a bit slightly thin. Okay, so now this briefly covers the autonomic supply to what we call salivary glands. And if you think whatever I've talked is making sense, is adding to you, please support me, and you can do that by a couple of means. You like the video, comment down in the comment section, and then subscribe. Thank you very much for watching. As always, until we meet next time.